Okay, so let's talk about the technology and the architecture that we use here in dotCMS. We propose and we encourage any of these three options for our clients. The simplest of these technologies is the single dotCMS node. This is where you have a single server to meet all your needs and demands. It represents a much simpler and straightforward scenario. Using this architecture, you can have your database and assets in the same machine, or you can have it in a remote file system as well. When I talk about assets, I mean any kind of file, such JavaScript files, velocity templates, PDF, image files, Word documents, PowerPoint presentation. Basically, any image that you upload, any image or file that you upload into dotCMS is going to be handled and is going to be referred by the name of assets. So basically, as you can see here, we have the front-end users, we have the dotCMS server in the same machine, in the same local machine that we have our caching, our index, our assets, and our database. Basically, in order to have a fully functional dotCMS instance, and your system administrator need to know this, in order to have, for example, a backup of everything in dotCMS, you need to have the assets and the database. This is because the database has some IDs that match the things that we have under the assets. So basically, in order to have a backup, a complete backup of the dotCMS instance, you have to back up these two things: the assets, that is a special folder in the file system, and the database that you're pointing into the dotCMS. The cache and the index are things that are built automatically every time that dotCMS starts, and you can also build that manually if you need to. So if you have the assets and the database, you can build these two things. So basically, the single dotCMS node is most used for us, the developers, and for clients that want to test things around dotCMS. Maybe the first day using dotCMS, and they want to see how to handle some of the different examples or needs that they need. So this is the single dotCMS node architecture, and this is one of the first thing that we are going to play with in dotCMS. We have a second option here. This is the multi.cms node cluster. And this allows you to scale up to meet the demands that you might have in your site. The nodes actually share the same database and the same assets. They have the Elastic Index. As a side note, remember that Elasticsearch framework changed its name to just Elastic. So if you need to search from documentation or examples from that, now it's called just Elastic. And also we have a cache that communicates with each other. So if a piece of information gets flushed out of the cache in one of the nodes, it will automatically get flushed out on the other nodes too. One of the main reasons people might go with the cluster architecture is because the load in their sites is very heavy and need multiple servers. This obviously gives you some redundancy and failover. So if for some reason one of the nodes goes down, you will still have another node that is up and running and taking traffic. In this scenario, you can also have a load balancer in front of the nodes in order to distribute the incoming requests among them. Now, the third option here is called the share nothing option, and this is relatively new. Basically, multiple single .cms nodes use a feature called push publishing. where you have, for instance, an authoring server, and you push changes to different servers which have their own database servers, their own assets, and they are totally independent from each other. And this gives you the scalability so you can grow as many servers as you need to. So the main difference, and we have clients using both things here, the main difference here is that this is going to share the multi.cms node cluster, or what we call cluster, is going to share the same database server and the same assets. The load balancer here is going to distribute each of the requests between the .cms instance. In this case, we have 3 instances or 3 nodes, each with its own cache and its own index. The communication between cache is very heavily when we are using when you're using the nodes and the cluster architecture, because we have to flush out, as I already told you, we have to flush out some of the things depending on when the request is done. And then the third option is not going to share anything. Right here we are sharing the database and the assets. Here we have assets and database for each of the .cms servers. So we have clients using both of the architecture here. Most of the clients use the cluster one because of the failover and the backups things that it has. Other, let's say 5 or 10% of the clients use this architecture. We have asked why the reasons behind doing this, because this is going to take more work. For example, one of the clients that use this architecture has some form submit that is very important, and they have to sync the information across the database. I think it's weekly, and they have to do this manually, and they are implementing a plugin in order to do it via code. But the main reason behind they chose this architecture is because they don't want to handle things like, for example, losing the database server connection and not having .cms capabilities. So in this case, they can lose some assets and they can lose some database that the load balancer is going to just point to the .cms server 2 and the .cms server 3. In the meantime, they figure out what happened for that server that is down. So basically, they can lose, in this case, they can lose 2 of the 3 databases or 2 of the 3 assets, and they can still run. They didn't like this option because seems like the database server, it's very unstable in their site. So they basically choose this. But the 90% of our clients are using this, the node cluster, and they just work just fine. So let's talk a little bit about kind of general philosophy and its relation with the technology and the architecture in dotCMS, which is really designed to support custom and dynamic content. And we want to do this as efficiently as possible. If we can make as fast or almost as fast as static content, we want to do that. One of the main ways to achieve that is that we minimize the amount of database calls. And we do that through a very heavy use of the indexing via the elastic indexing, and also the caching via a framework called Wawa Cache or Hazel Cache in recent releases. We actually open our implementation for the cache part of .cms in order the clients to they can implement their own caching, For example, we know of clients using Redis, and they implemented that code using OSCI plugin, I think. But basically, we have several implementations that you can use in order to use your required cache. By default, we use the Hazel cache in the, I think it's from dotCMS 4.1 or something like that. We use Hazel cache for the cache framework in dotCMS. So basically, elastic indexing and the caching are tremendously useful in a wide variety of cases. Between these two techniques, we are able to minimize the database calls. There's been cases when the client's database crashes and they didn't detect that right away because we have dotCMS using and is still fully functional using the caching and the indexing, which we think that is very, very, very cool. We have two different types of caching. We have the page cache and the block cache. Basically, the page cache is when you set up an HTML page in dotCMS and you set up the page cache. It is very important because it is the most efficient and the most performant cache. Our system is kind of like a big velocity engine. So what it does is processing everything that it needs in order to render a page, and it caches that in memory. So if you have that set up, you're going to see a response for every request almost as fast as a static HTML page. So when this caching happens, it already processes all the velocity code. It doesn't need to do it again. It will just send the string representation of the page back to you and serve that into the front-end user. So hitting that content is almost as fast as hitting the static content that you might use in a plain HTML static site. You can set up the page level cache to like 15 seconds or to 1 hour, 6 months, whatever you need, depending on how often your page will change. Even a 15-second cache will make a huge difference in terms of the performance of dotCMS. So basically, you might be asking where you configure that. Let me just go into the demo site. We have a demo site. I guess you might already have gone through that. Well, we have a demo site. It's going to be demo.cms.com / it could be admin, it could be C, and it could be .admin. Those are shortcodes in our what we call the backend of .cms. The backend of .cms is calling it backend. It's very confusing between across Java developers or any other kind of developers. But basically, what we call backend of .cms is the admin site, where you go into change of the configuration of the .cms, changing or editing pages or content. So that's the backend of the .cms. And the front end, of course, is the site that the front-end user is going to take a look. So basically, if we go into the demo site, into the backend, and if we input the default credentials, it's going to be admin at .cms.com, and the password is going to be admin. This .cms instance gets or resets every 12 hours. So this is very cool in order to test small things or do some small examples. We'll be aware that this resets every 12 hours, so you cannot do heavy stuff in here. And so basically, if we go into the .cms backend site browser, let's click on the index page. If we right click here and open the page properties, we are going to see this option at the end of the content tab here, and it is called the cache TTL, and right now it's set up to 15 seconds. So basically, this is the page cache that I was explaining to you. In this case, is set up to 15 seconds. So this means that every request that comes into the .cms demo site for this page between the 15 seconds lapsus is going to respond already cached page. So basically in .cms what we do what we do is just render this page, grab all the images, grab all the contents, render the velocity things. So we have everything. We render that in the velocity engine, and the resulting HTML code, that's what we are going to cache, in this case for 15 seconds. So for example, let's say that you might have a contact us page that it doesn't get refreshed that often. You can set up that TTL for like 2 weeks, 1 month, or something like that. So that page, that HTML page content is going to be stored in our page cache for 2 weeks or for 1 month. So every time that a front-end user hits that page is going to be just as fast as returning HTML code. That's what we are returning from the page cache. So by using the page cache, we are avoiding every process of the velocity, every hitting of the database things, or the elastic, or the caching. We are avoiding everything, and we are returning that. So it is very cool, and it is very important to understand that you have that possibility in order to avoid that many overhead into the process of the servers. The other caching that we have here, it is the block cache. So maybe you have a similar request. You have a contact us page that doesn't get refreshed very often, but it will show up different things depending on the type of the user. So for example, signing in as an administrator and someone else signing in as a limited user, both users might view different things. So in this case, you can create what we call a block cache. This means that you can cache only a part, a block of the page, a chunk of it. So you can specify that. So for example, between point A and point B, the block will be cached and you can give it a key. The main point here is to understand the difference between these two caches. If you use the block cache, we'll still have to parse through all the velocity code to find those block caches and reuse them, which means that we add some additional overhead. In the other corner, we have the page cache that is much more efficient because the velocity code has already completely been parsed. And the string representation of the page is what we are going to store and what we are going to return. One important thing here is that the cache can be purged, can be deleted from a specific page when the authors change a piece of the content. So for example, if we go ahead here, let's say that, let me just go here. Let's say that you have 1 week of page cache for the index page that we are taking a look right now. If a content editor or if someone else is working in this page and make changes and hit the publish page or the save and publish button, it will automatically get flushed out of the cache from every of the servers that you have. It could be locally or it could be every server in the cluster. And the new version, the updated version of the page will be generated. It will be stored in cache and it will be available for all nodes because you edited this page directly. However, let's say that your page has, for example, a news feed widget that it got or it gets a new story added every minute. This updating of that page will not mean that every page in the entire system using that specific widget will be flushed out of the cache. That will have to be have to done via the manual or resetting the cache of that specific page or pages. Of course, you can disable all the caching for the serving pages, but must be aware that there is a performance penalty that comes with that. You can set up the page cache in the backend in the proper page, as we just saw. And the block cache has to be implemented through the velocity code. As a side note, please take into consideration that the block cache is only available with an enterprise license. It is not part of the community version. And then we have a lot of the third-party libraries in order to avoid reinventing the wheel. They are all proven solutions to our problem, and it saves a great deal of time in our development phases. So basically, with that, we explained a little bit about the technology and the thinking behind the dotCMS source code, and then we are going to talk about some of the things that we support and the technology that we use. Okay, so about the technology and architecture, in that lane, we come pre-bundled with Tomcat. As you already saw, the official distribution of dotCMS has a Tomcat 8 application server inside the package that we come pre-bundled. But in total, we support 4 different application servers. We have JBoss, WebLogic, WebSphere, and of course the Tomcat one. Also, in the databases engines, we support Postgres, MySQL, Microsoft SQL Server, Oracle, and since 3.0, I think it was the version that we released, a fifth database called H2. This database is really intended for development purposes only. We are going to play with it in some of the first examples that we are going to see in this training. It is enough to showcase what you can do in dotCMS for local environments and for evaluation, but it is not recommended at all for the local development machine and the official production environments. It's because the H2 database is very similar to Microsoft Access. I don't know if that still exists, but basically it's a file database, goes into the file system, and H2 doesn't allow more than one request open, one connection open into the database. So basically, it is fun to play with it. It is very easily. We come pre-bundled with that because it is very easy to just start playing with dotCMS. You don't have to worry about configuring anything else. It works for us to showcase dotCMS for clients or new people that want to test that. But basically, it will not work, and it will be not functional for people that are working, are developing, or are in production environments against that. So just to take in mind that we use 1.7 version of the velocity, in case that you would like to go through the official velocity documentation. This is a very, very active project. We have customized velocity quite a bit in our system. Basically, we fork velocity in version 1.7 for performance and for other reasons, but their documentation still works pretty well for any doubts or best practices that you might want to know. For Elastic, we try to stay pretty up to date. Our indexing engine, this is a key part of dotCMS. This is a very active project too. You can check their website and documentation. They have a lot of it and also resources available. For the caching, before the 4.0 series of dotCMS, we used to have the Google Wow cache. As I told you, we opened that implementation in order the clients can have their own caching environment. So right now we are using Hazelcast. This is the latest one and the most modern type of cache that we are testing, and that clients are very happy with it. About the caching for a single server is pretty straightforward, as you already saw in the diagram of the shared nothing or in the single.cms architecture. For a cluster environment, you just need to understand that the caches live, we have one cache for every of the nodes, but they talk to each other. This means that if you go to a page and make a change, and you publish that page in one of the nodes, let's say node A, that page will be popped out of the cache in both node A and node B, in case that you have two node clusters, and it will be lazily load back based on what is requested. So if it is requested in node A, the page will be in cache in node A, but not in the node B, until someone asks for it in node B. For most of the caches, this example was of the page, but for most of the example, it works just the same. The communication is in order to remove or to flush out something of the cache between the other nodes, in order to not have integrity problems between all of the clusters. It is easier and safer for us just to go into the database if it is not into the cache, that keep trying to sync up everything inside the caching of each of the nodes of the cluster. So basically, when you remove one things on one of the servers, it will be flushed out from all of the other ones. But if you are loading or if you are putting something in the cache, it will be lazily loaded back. We had before the Hazelcast implementation, we had J groups. This was a framework that we used to allow that nodes to communicate with each other in the cluster environment. It is a toolkit for reliable messaging. Hazelcast, and one of the reasons that we implemented Hazelcast in our latest releases is because they have this communication, this talking of reliable messaging. They have that bundled with the caching infrastructure, so we don't have to have two different frameworks in order to do so. About Hibernate, this is very important. We are discontinuing it. We are not very thrilled with the things that it does and the performance in some of the areas. So in the new code that you write, we encourage you to not use Hibernate, since we are moving away from it internally. The replacement framework that we are going to use, it is we have an internal framework that allows us to run SQL queries directly without any other tool in the middle. We're going to see an example of this in the last day using this framework, this dotCMS framework for talking to the database. This allows us to have more control on the data, achieve better performance in the queries, and get rid of the situations where the Hibernate session can be very, very tricky. Most of the other libraries that we tested for the database are not adequate to deal with the way that we do things in dotCMS. So at least for the moment, we are interacting directly with the database ourselves. There are a lot of frameworks and libraries that we use for our user interface and also the backend. We have, for example, the strokes for displaying portlets. We have Spring if the user wants to develop a new page on their own with some business logic from dotCMS. We still have Dojo for user interface for the mobile windows, for some of the widgets, but we are working since the 4.0 series in dotCMS, we are really working on migrating everything that we have right now in order to be a REST architecture between the backend and the front end in order to be able to use different frameworks in the UI. Right now, we are using Angular. That's what we chose for our new user interface. So we are migrating everything from the Dojo and from the JSP to the Angular side. This will allow us to create a lot of REST endpoints from the CMS backend or from the content or the editing things in order to be able to be used by you for I don't know, maybe you want to develop a mobile application or an iPad admin site or something like that. And also will be able to reuse those REST endpoints and test very carefully around it in order to use as our main endpoint to the Angular. We have other libraries and frameworks like Quartz. This is a very important framework that we use in dotCMS. Quartz, it's basically creates scheduled jobs that will run in a specific moment. This is just like the cron jobs that Linux or the Unix has. We still have some DWR framework in order to communicate from JavaScript to our backend services, but we are removing those also in order to be replaced with the REST calls. Just go to the next page here. Okay, so talking about the source code, we have to understand the difference between the legacy and the new code. To give you guys a little context about our company, long before my time, dotCMS used to be called dotmarketing. And it was a marketing company that built custom websites using LiveRay portal. So we use a pretty known CMS that is called LiveRay. We use that in order to build websites for different clients. Each of the CMSs and each of the portals or websites that we build for our clients were customized according to the client needs. Creating such a high amount of site customizations involved a lot of work and became very complex. So dotmarketing decided to create its own product, which was based very heavily on the library, of course, and also integrating a lot of the customizations that we already had for all of the clients that were coming all together. This was the beginning of the dotCMS. It was called dotmarketing, and then this was the beginning of dotCMS as a company and the product that we are selling now. Now I think we contain like more than 3 million lines of codes, a fairly large system with a lot of features, and we are really focused on providing a very flexible product that will also allow you to interface with other softwares and will help you to create custom solutions very quickly. So the old source code use several factories. So when you see in the new code what we call API, this is the new way of interacting with dotCMS. Factories are still used by some of our clients, so we don't have or we don't really need to deprecate that before giving them plenty of time to move into the new APIs. But most of the things are using APIs right now. Also, and this is very important for the second time, Hibernate. This is going to be retired in the newer releases, so please, we suggest to not use that, or at least create a dynamic plugin. Those are the ones that we are going to see in the third training if you need to use Hibernate on your own business logic. But for dotCMS, we don't recommend and we don't try to support in the future releases the Hibernate part.